we had a certain discussion, no? Like y equal to omega square r square by 2g. Why can't we use that formula straight away? We had some discussion, will I agree? Can we take help of that discussion what we made? Okay, no, let's get into the problem. He's asking what should be the omega for this to happen. Okay, if you don't rotate, what will happen? So let it not be rotated. Then for equilibrium, the pressure on this side, I think better if you can start the problem like this, you'll be in a little bit on safer side. Means what I'm studying, you'll understand very easily. It should be in equilibrium. So the level of liquid should be equal. Should be same or different here. See, it should be different. So we are not bothered. So the lighter one will rise to more height. The denser one will be like this. Okay, now take this one, and this will be this one. So the total volume should be conserved. So this will be, I don't know, y1. This will be x1. This will be x2. This will be y2. Only one help is the pressure at 1 should be equal to pressure at 2. Pressure at 1 should be equal to rho g y1 should be equal to 2 rho g y2. So y1 equal to 2y2. And x1 plus x2 should be equal to 7h. And total volume of liquid. So this y1 equal to y2 we have. So then what is other equations? We can write it as y1 plus x1 plus x2 plus y2. This should be equal to how much? 3h, 6h, 6h plus 5h, 11h. And x1 plus x2 is how much? It should be equal to 7h. Okay, I do have two equations to unknown. Solving, I'll get y1 and y2. Will I agree this? This should be the state because of what? Because of if there is no rotation. It's stationary. Y1 equal to y2. Let me substitute 2y2 7h plus y2 equal to 11h. 3y2. So 11h 3y2. So y2 will be 4h by 3. The lighter one should rise more. This should have been this one. If you rotate it, they will occupy this position. See, please try to understand like why you are doing this problem. I think this is very important. Without that, you'll be in a big trouble. If the tube is stationary, this should have been the levels. So then if I rotate it, they will acquire this particular state. So for that, what should be the angular velocity? Getting this one? So please try to understand. So now we'll get into the problem. So shall we directly take the question now? So what should be the omega? What are the forces you are supposed to equate here? I'll directly jump into the discussion. Here, there's a point 1, point 3, there's a point. It is rotating. So the pressure at 3. So I'll use the, just now earlier I used pseudo force. No, the same idea I'll use. Or else, no, sir, I'm getting confusion a little bit. Okay, you want to take small diagram. The pressure at 3, it will exert a force P3 into S. This will be P1 into S. Here a pseudo force should act. How much it should be? Rho omega square. If this length is x1, you call it. I think that length should remain same, 4h only. or time being you write it x1. So x1 square by 2. So equate the forces now. P1s plus rho, density of liquid is rho, no? Rho omega square x1 square by 2 P3s minus 0.
Sir,
P1s, yeah, ma.
is it x1 by 2 whole square, sir?
X1 by 2. Okay, I had to write it whole square. Omega square, okay, the x1 is the length I picked up. X1 by 2 whole square it will come. Pseudo force m omega square, or else we can integrate also. What is there in that one? You take small element dm omega square x by 2 will be there. Oh, sorry. I think you are. You mean to that square should not be there? No. Okay, why by 2? Why not whole square? So if you're getting confusion, so we'll begin like this. Small element, you take it dx. This is dm. Then how much of pseudo force dm? We assumed it at a distance x. Then what is the pseudo force will be? M omega. So total length is x, no? So dm omega square x you are going to write it. Then, so what is the pseudo force will be? Pseudo force Fc, I'll write it. Pseudo force F should be equal to integral of dm omega square x 0 to x. I'm just trying to show that rho s dx omega square x 0 to x. So rho s omega square x dx 0 to x. Okay. Shall I write x by 2 whole square or x square by 2? X square by 2 only. Okay, this discussion, I'll keep it. This will move it down. I need space. Okay, ma. Some of you are asking like a x square by 2. If I write x by 2 whole square, what is the meaning of that? I think there is some reason is there why we are writing that pseudo force in this way. So shall I write directly rho because let me save some time. Oh, this is needed. No? Let's come for this one. If length is x1, then this will be the condition. I think I'm not confusing with so many diagrams. So shall we write pressure equation in this way here? What is x1 here? X1 should be the length of this column 4h. Solve it, you'll get relation between P1 and P3. Similarly, shall we write between P3 and P2? So the one S will also be there. P3S plus rho omega square 3h whole square S minus P2S equal to 0. Okay, what about P2? Can you write anything about P2? But what was our question? So P3 can we eliminate S by using these two equations? P3 will eliminate here. After eliminating, then P1, P2 are unknown. So shall we write P1 is equal to rho GH and what is P2? P2 should be equal to rho G 3H. So solving equation 1, 2, 3, we'll get expression for omega. This y rho omega square, it should be written the pseudo force you have to for the liquid column due to rotating liquid column. Why the pseudo force should be the condition. I think there's a way of writing directly. If you're writing the forces here, if you're writing pressure, this S should not be there. So shall we make a rule now in a rotating liquid column, how to write the manometric equation? So I think now I'll take you to the writing equation. Looking at this. No, don't bother anything. So what is the pressure at 1? P1 plus rho omega square 4h whole square by 2 minus P3 equal to 0. Writing manometric equation in the rotating liquid columns. I think nothing wrong, no? P1 plus rho omega square 4h whole square x1 will become 4h minus P3 0. Similarly, if I write from P3 to P2, P3 minus 2 rho omega square, what is the length of liquid column? 3h whole square minus P2 0. Fine. As a teacher, I think I was supposed to, here 2 rho is there, density. Try to see this. So I derived it, but hereafter, directly in exam, you're supposed to think here. Rotating liquid column. No problem. Or sir, I want to write manometric equation from here to here. Straight away you write it, no? So pressure here P naught plus rho GH. Then rho. So if you are very smart enough and want to save time, no? So what is the equation you're going to write? From A to B. Pressure at A, PA plus rho GH minus rho omega square 4h whole square by 2 minus 2 rho omega square 3h whole square by 2. Then I'm going to rise up inside the liquid. So this should be 2 rho G 3h or 3h minus PB equals 0. And we know PA equal to PB equal to P naught. Same thing will get it. So this is one. No need to do that. This directly writing manometric equation. I think there's a skill what you should acquire. Say this, all this will come not like in this one. When you do numericals and start analyzing, oh, can I think like this also? Oh, fine. So why to write from 1 to 3, 3 to 2, again a pressure at 1, pressure at 2, straight away from A to B you write it. Omega